Hello everyone, I Nikhil welcome you to Vigyan Bharat. We are back again with another interesting video. In this video, I am going to discuss a very interesting problem from TIFR GS 2021 Mathematics Entrance Examination. The problem is question number 7. Let's try to understand the problem first. Again, it's an MCQ type problem. So what it says that we are given a set A, be the set of all real numbers consisting of this scalar lambda which belongs to the interval 0, 1. So we are considering all the possible scalars which belongs to 0, 1 closed interval such that scalars satisfy this equation. We are looking for all those scalars such that limit of this left hand side log, in the argument we have lambda 2 raised to the power p plus 1 minus lambda 3 raised to the power p upon p when p tends towards 0 equals lambda log 2 plus 1 minus lambda log 3. So we have to find the values of lambda, because since it's an MCQ type problem, so certainly one of the given options out of the 4 is correct. And before moving ahead with the problem, first we're going to make some observations. For what value of lambda we're going to solve this problem. Since if you see, this number 0 is present in all the 4 options, so certainly lambda equal to 0 satisfy for this equation and we don't need to check for that value. Again, lambda equal to 1 is also a member of all the 4 equations. Now there remains lambda equals to 1/2, which is a member of this option C and option D. Lambda equals to 1/3, again which is the option in option C and D, and finally lambda equals to 2/3, which is only common to option C and D. So if I can check for these particular values of lambda, whether lambda equals to 1/2, lambda equals to 2/3, lambda equals to 1/3, if for these values of lambda I can check the problem, then I have eliminated the rest of the problem options and the problem is solved. So let's move ahead and try to understand how we solve this problem. It's a very interesting and easy problem again. Try to see this one by one. We are given an expression of the form which I gave a name. I call it equation 1. This is what I have just explained you above, that lambda equals to 0, 1 belongs to all the options, so we don't check for them. Okay. Let's move ahead now. I am now considering whether lambda equals to 1/2 satisfies equation 1 or not. So it's quite easy for checking whether it satisfies. I have to check the left hand side as well as the right hand side. So first I consider the left hand side of this equation number 1. I replace lambda by 1/2 here everywhere in the left hand side expression, as well as I have replaced in the right hand side expression, and I have to check whether these two are equal or not. If I replace lambda equals to 1/2 in the right hand side, it will be 1/2 log 2 plus 1/2, that is 1 minus 1/2, that is 1/2 log 3. In the left hand side, when you will substitute the value of lambda to be 1/2, then 2 raised to the power p is already there, and this 1/2 will come here in place of lambda. So if you simplify, you will going to find it 2 raised to the power p minus 1. Similarly, here it will be 1 minus 1/2, that is 1/2 into 3 raised to the power p. So this will be like this and p will be there. Okay. So now let's try to solve it. If you see here, when you are going to replace the value of p by 0, because you have to calculate the limit of this expression when p approaches 0, you can simply take the limit inside because log is a continuous function. So if you take the values of p around 0, using algebra of limits, the numerator is going to become 0 and the denominator will also be going to become 0. When you're going to replace p by 0, so it will be 1/2 plus this is going to 1/2 and 3 raised to the power 0 is 1. So in the angle of log it will be 1, so log 1 is 0. So that's why it is a 0 by 0 form, which we know is an indeterminate form. What is it? It is an indeterminate form. And to solve such a kind of an forms, we apply a very famous technique known as L'Hopital's rules. In that rule, what we do, we simply differentiate the numerator as well as the denominator of the expression and then apply the limit. Now here, as we are taking the limit with respect to p, so I'm going to differentiate the given above expression with respect to p. This expression, when I'm going to differentiate, you can easily do that. So it will be derivative of the numerator as well as the derivative of the denominator. So derivative of the numerator, you will going to use the definition of log function. Derivative of log is 1 by the argument times the derivative of the argument, which you can easily calculate, and the derivative of p with respect to p will be 1. So this will be the simplified expression when you are going to calculate the derivative. Now in this you can simply substitute the limits. So when you will going to replace the limit, this will become 1 and this will become this expression. And this coincides with the right hand side, which we have already calculated above. So in this case, lambda equals to 1/2 satisfies this equation because left hand side equals to the right hand side. So lambda equals to 1/2 is a candidate. When lambda equals to 1/2 is a possibility, so option A can be discarded now. Okay, because 1/2 does not belong to A. Now we move ahead in a similar approach and check for other values of lambda. Now we check for lambda equals to 1 by 4. When we are going to check for lambda equals to 1 by 4, the left hand side of equation 1 will going to take the form of a 0 by 0 form, and again when we are going to apply the L'Hopital's rule, a similar approach, simply differentiate the expression using the definition of log function, and derivative of p again with respect to p will be 1. So this will be the simplified expression, and if you will going to calculate the limit of this using algebra of limits, so you simply calculate the limit of this thing and divide by limit of this thing. So when you calculate the limit, it is going to come out like this, and separately when you're going to replace lambda equals to 1 by 4 in the right hand side of equation 1, if you replace the lambda equals to 1 by 4, so it will be 1 by 4 log 2 plus 1 minus 1 by 4, 3 by 4 log 3, 1 by 4 log 2, 3 by 4 log 3. So when we evaluated the limit, this will be 1. If you take the LCM, this will be 1 by 4 log 2 plus 3 by 4 log 3, which is same as the right hand side. So what I have done, I have simply checked for lambda equals to 1 by 4. See how smartly I have solved this problem. I just first check for lambda equals to 1 by 2, so which discard option A. Then I checked for lambda equals to 1 by 4. I checked for that value of lambda which is not present anywhere in the above 3. In starting I have said something wrong. I said that we have to check for all these 1 by 3, 1 by 2, 2 by 3. No, what we have to do, we have to check for that particular value which don't lies in any above the above 3 sets. So in that case, when I check this equation, this expression for lambda equals to 1 by 4, then I found that it satisfies this equation, and it is not a member of neither of this nor this nor this. So D, option D is the correct option. The closed interval A consisting of 0, 1 will be all the possible choices of lambda for which this above equation is going to hold. That's what I have mentioned here. This choice discards option A, B, C, and therefore D is the correct option. I hope you find this explanation quite easy, and if you have any doubts anywhere, you can ask me in the comment box. So that's it for this video. Before concluding, I'm going to just share one information with you. If you are someone new to a channel, then you may join our community, for which you can join our Telegram group, whose link you can find in the description of this video. And if you like this video, then do give us a like, and for getting our notifications at the earliest, you may subscribe to you may also subscribe to our channel. So thank you so much for watching, and we'll be moving ahead with some interesting video. So thank you so much.